The most significant recent development in solar sail technology is NASA's Advanced Composite Solar Sail System, ACS-3, mission, which successfully launched and deployed in April or August 2024. This mission is crucial as it tests next-generation carbon fiber composite booms. Unlike previous solar sails that used metallic booms, the ACS-3's composite booms are 75% lighter and far more resistant to thermal warping in space. 3. This new material allowed the compact CubeSat to deploy a large 80 square meter, $4/approx 860 square feet $1 sail, about the size of 6 parking spots. 5. Successful testing of this deployment paves the way for future, much larger sails, potentially up to 2,000 square meters, for deep space exploration. 6. The Pulsar Fusion Sunbird is a revolutionary concept for a fusion-powered migratory transfer vehicle or space tug, designed to drastically cut interplanetary travel times. It is powered by the company's proprietary Dual Direct Fusion Drive, DDFD, a compact nuclear fusion engine performance. The Sunbird is theoretically capable of reducing the travel time to Mars by half, to around 3 to 4 months, and reaching Pluto in approximately 4 years. 4. This is achieved through an extremely high specific impulse, $5.10, 00015, 000 seconds $0.6 dual function. The DDFD is designed to produce both thrust and up to $7.2 MW of electrical power for the spacecraft's payload upon arrival, eliminating the need for bulky solar arrays in deep space. 8. The space elevator remains a major focus of futuristic infrastructure, often referred to as the Green Road to Space for its potential to replace costly and polluting rocket launches with electric-powered transport. The latest developments are heavily centered on 2 core areas: materials science and alternative concepts. The traditional vision requires a tether of extreme strength, $2.100 times $1 stronger than steel, a material hurdle that carbon nanotubes, CNTs, or graphene are their eyes to meet. Though large-scale production of flawless cables remains a challenge that in the near term, concepts like the lunar spaceline are gaining traction. This alternative proposes anchoring a tether to the moon and extending it toward Earth's orbital space, which significantly reduces the required material strength, making it viable with current high-strength polymers like xylene. SpaceX's Starship, the fully reusable, 2-stage launch system, has seen significant advancements and iterative design changes in its test flight program, with the final second-generation, V2, flight occurring in October 2025. The vehicle is the most powerful rocket ever built, standing about 121 meters, 400 feet, tall, and is the key to SpaceX's goals of Mars colonization and the NASA Artemis 3 human lunar landing, as the Human Landing System variant, scheduled for 2027. The system is powered by Raptor engines which burn liquid methane and oxygen. Recent V2 test flights have focused on achieving high-speed milestones, demonstrating full-duration super heavy booster burns, successful hot staging separation, and controlled, albeit soft, splashdowns of both the booster and the Starship upper stage in the ocean. Polaris Dawn was the inaugural mission of the private Polaris program, commanded and funded by billionaire Jared Isaacman. The mission, launched aboard a SpaceX Falcon 9 and Crew Dragon, Resilience, on September 10, 2024, achieved several historic milestones in its 5-day flight. Highest Earth orbit, the Crew Dragon flew to an apogee of 3.1408 kilometers $1, 4.875 miles $1. The farthest a crewed spacecraft has ventured from Earth since NASA's Apollo program. 5 high-altitude research. The crew flew through parts of the Van Allen radiation belts to conduct $8.36 research experiments, focusing on the effects of space radiation and decompression sickness on human health. Starlink laser communication. They tested the first Starlink laser-based communications system aboard a crewed spacecraft, a key step for future deep space communications. The O'Neill cylinder is a 1970s concept for a self-sustaining space habitat, but it remains highly relevant today as a long-term goal for space colonization. Championed by figures like Jeff Bezos, the latest details focus less on construction, which is still decades away, and more on the technological pathways and economic justification. The classical design, two counter-rotating cylinders, 4 miles in diameter and 20 miles long, providing 1g artificial gravity through rotation, is now seen as the ultimate habitat, likely built after smaller prototypes like the Benol Sphere or Stanford Taurus. Autonomous construction, robotics, and in-space manufacturing are essential to assemble structures of this size in a vacuum. Closed-loop life support, creating a stable, self-contained ecosystem, including atmosphere, water cycle, and agriculture, is the most complex biological engineering challenge. Asteroid mining. The cylinders would require billions of tons of material, necessitating the development of cost-effective space resource utilization (ISRU) from the moon and asteroids to avoid the massive cost of launching materials from Earth. Virgin Galactic, the company pioneering suborbital space tourism, is undergoing a major technological transition. Following the final commercial flight of its current spaceplane, Versus Unity, in June 2024, the company is now fully focused on developing its next-generation fleet, the Delta-class spaceships. The Delta-class is crucial for scaling up operations. Unlike the Versus Unity, which carried 4 passengers and could fly about once a month, the Delta vehicles are designed to carry 6 passengers and fly up to 8 times per month. This dramatic increase in cadence is intended to clear the customer backlog and achieve profitability. Key development milestones for the Delta class include the establishment of a dedicated ground testing facility, Sunbird, in Southern California, and final assembly plan for a new facility in Phoenix, Arizona. The Sunbird is the flagship project of UK-based Pulsar Fusion, envisioned as a revolutionary nuclear fusion-powered space tug designed to drastically reduce interplanetary travel times. Point 2. The latest focus is on the Dual Direct Fusion Drive, DDFD, a compact engine that aims to produce both thrust and continuous electrical power. $3.2/text, MW. Point 4. Pulsar Fusion is also leveraging AI to refine the linear reactor design, pushing the boundaries of high specific impulse, up to $9.15,000/text, S or $, making it a significant challenger to current chemical and electric propulsion systems. Point 10. The Rockwell C-1057 is not a recent invention but a historical, unbuilt design from the early 1970s, making it a piece of space history rather than current technology. It emerged during Phase B studies for the Space Shuttle program. This concept, nicknamed the Breadbox Shuttle, was engineered by Harry Scott to address NASA's need for an orbiter with a standard-sized cargo bay but a minimized length. His unconventional solution was to rotate the large cargo bay sideways relative to the direction of flight. This resulted in a unique, short, and squat vehicle profile, a dramatic departure from the final, more conventional delta-wing space shuttle orbiter. Ultimately, the C-1057 did not advance beyond the proposal stage. Its unusual configuration raised questions about its aerodynamic performance and, crucially, NASA's X-59 Quiet Supersonic Technology (QSST) aircraft, built by Lockheed Martin, recently achieved a major milestone. Its historic first flight on October 28, 2025, from Palmdale, California. The X-59 is the centerpiece of NASA's Quest mission, aiming to solve the decades-old problem that grounded commercial supersonic travel over land: the loud, explosive sonic boom. Its unique, long, chisel-shaped nose and carefully designed fuselage are engineered to manipulate the shockwaves produced at supersonic speeds, up to Mach 1.4, or $/approx 925 miles per hour, or $. Instead of a deafening boom, $/approx 110 \text, dB the $. The aircraft is designed to produce a soft sonic thump estimated at around $75/text, peeled to be $, similar to a car door closing. The Blue Ring Pathfinder is the inaugural demonstrator payload for Blue Origin's full Blue Ring space mobility platform. Launched on the first flight of the New Glenn rocket in January 2025, the Pathfinder successfully validated key systems for the future commercial platform. Blue Ring itself is a hybrid solar-electric and chemical-propelled space tug and host vehicle, designed for multi-mission, multi-orbit operations. Its core capabilities include maneuverability. The full version will offer $4,3000/text, E4000/text, MOS, $, of delta V, enabling transfers to high-energy orbits like geosynchronous equatorial orbit, GEO, cislunar space, and even Deep Space Point 5 payload. The Céleste capsule is the core component of French company Zefalto's luxury space tourism offering. This pressurized, architecturally designed cabin is carried to the stratosphere by a massive, zero-emission helium balloon. Latest details highlight a refined focus on the passenger experience. The capsule is designed by renowned French architect Joseph Durand and features the largest panoramic windows on any space capsule to maximize views of Earth's curvature and the blackness of near space from its cruising altitude of 25 kilometers, 15.5 miles. The interior is divided into 3 intimate, 2-person cocoons with comfortable seating. The 6-hour journey, set to potentially launch as soon as late 2024-2025, will include 90 minutes for ascent, 3 hours at maximum altitude, and a 90-minute descent.